Hello guys, welcome to another video tutorial about procedural modeling. In this one, we're going to do something a bit more interesting. We're going to make a kind of like a sci-fi stair, kind of like platform kind of thing, and we're able to control its length and its turns and the stairs, of course, right? Things like that. So yeah, let's start building it. I'm going to go start with a geometry here. Okay. And call this guy Stair, right? And then inside of the stair, I want to try to build some basic foundations of the stair. And this is going to be actually really close to my other tutorial on the comparison. So we can start with something like an add node to basically have a point in there, right? And then we can control the, we can then add new points, right, to build the stair. So attribute wrangle here. Okay. And say int stair count will be equals to channel of an integer stair count. Okay, right, we have this, and then we just need to do a for loop. So for int stair equals to 0, stair is smaller than stair count, and then we increment s. Okay, and then we add 2 points, right? So we can say vector. Oh yeah, we just need to know the previous vector location, previous point location. Previous location will be equals to, in this case, 0, 0, 0 for the first point. Okay, right, and then we just keep adding new ones and updating the previous location. So vector point 1 location, we add 2 points, right? Point 1 location will be previous point location, right? Plus a vector that is, you know, getting just a little bit higher, right? So it's going to be something different here on the y. So we can define a attribute for that. Float stair height will be equals to channel stair height, right? This is gonna be stair height. Okay, and then we just need to also know another one for stair depth be equals to channel stair depth. Okay, and then vector P2 location will be equals to previous location plus set. Oh, you know, we can just do P1 location actually. And then we offset it with, this time on the x direction, stair depth. And then 0, 0 for the y and z direction. And we add those 2 points, right? Add point 0, P1 location. This is going to add to the first input, right? And then we add another point. Another point will be also 0, and then P2 location. Okay, and then we also wanted to add, right after adding those 2 things, we also wanted to add, oh, actually we don't want to add anything, we just need to update the previous location now. The previous location will then update it to the current P2 location in its loop. Okay, run this, and then we click on that to have our input and drag these things up. Right, you can see we're having this stair-like structure. Right, we can control the amount of, oh, that's the count, the height, and then the depths. Okay, then we add one last point will be like last vector last point location will be the previous location, but with the y zeroed out. So it's going to be a value of this x, and then 0, and then z. Okay, and then we add a point over there. Okay, oops, got an arrow. And here it's going to be a point. Okay, now we're adding another point down there. Let's take a look at the points, and yeah, and then we just, you know, positioning, stair positioning. Okay, and then we do a add command to add the staircase with polygon by group and closed. Right, cool. So this is gonna give us a bunch of points. Sorry, a bunch of points here. Now this is gonna be the basic structure, but you can do whatever you want with this. It doesn't have to be like extruded from this. You can populate your staircase along or on those points in whatever way you want, right? Yeah. So in this case, for every other point here, you can add something like a plank or whatever to have the stair structure, right? We can of course do that if you wanted to do it that way. Okay. So actually it would be easier to have those things right here. We can add another point in between. Another point. Add point. And this one will be adding to the middle, so we can easily populate stuff in there. So we can say vector p3 location will be equals to this. I will add it in there. But for p2, we want it to be somewhere in between p1 and p3. So this will be the stair depth divided by 2. Okay, right. And whoops, that's not looking very good. Let's take a look at what's going on. So 0, 1, 2, 3, 4. Oh, that's because this is p3 location now. That's fine. Right. So we're adding one more point in the middle. It's not maybe not necessary, but I'm kind of wanted to have like a way to position those guys, and we can say int middle point. Oh, actually this one, int middle point will be equal to that. Okay. And then we can say set point group for this new point. Middle point. And we can use this is the second argument should be the name of the group. So populate points will be equals to 1 for the middle point. So we can say middle point here, and then 1, right? So this will give the middle point a special group. These guys. We can even test that by doing a blast. Here, we go to the group and blast out these. You can see now those points are gone. We can do delete non-selected, and we got those points. Those points can be our way to populate extra stuff here, right? If we have like those cool like metal grade, we can populate those in there. In fact, let's actually build that. Okay, so I'm gonna do another grade here. Okay, and size has to be the same size, same length at least in here, so we can go ahead and get that. Okay, we can go grab the stair depth and copy that and put it in here for the size X, I think. So paste it in there. Paste the relative reference. Okay, for the Z, let me go for 2 for now. Okay, we can lower down the rows and columns, and we got something like this, right? And then basically do like a convert line. Yeah, that would work right away. We convert those into lines, and then we can do a poly wire here, and that will give us this like a grade. We can lower down the radius, of course, right? And then maybe we can give it a cool frame, right? So in the grade, we can do like a group. Okay, for the group, what we want to do is we want to group the edge here, and that's going to be here check out the base group we do on the edges, include that edge, and we can say on shard edge. That will group these guys. So we can do like a blast again to blast out the group 1 here, which is, let's name this guy actually, edge group. Okay, and in the blast, we blast out the edge group. Blast delete non-selected to give us the edge. Okay, there's a bunch of things we don't really like to have. So again, I'm gonna do a probably can do that on the convert line. Let's take a look. Nope, that's not gonna work. Let's just go back here. We have some triangles here, right? We can do a add surface operator, and we can just delete geometry but keep the points, right? And the points should still have the correct order. Actually, it's not. Okay, so we can do some sort here first. Not sure if it's gonna work then, because it's not doing that thing. How about this then? We don't do it this way, we do it the other way. We can do like a divide. Another way to gather the lines here is just using a divide node, check out the convex polygon and remove sharp edges. And then we can do a facet. This facet will allow us to remove the inline points, so give us this square-like shape. Yeah, that's what we want. Okay, and then we can do a extrude, poly extrude. We can extrude inside in, right? We can output the front group, right? Actually, we can maybe choose to not up. Yeah, that's actually all we have, all we want. So we have this little frame, right? We can then do a game. Actually, let's just type in second. Yeah, game dev second thing. It's a pretty cool stuff. Those game stuff is actually new to me, and they're really cool. And you can choose things out. You can do both directions, right? That's gonna save you a whole lot of time trying to like do all the operations yourself, right? And then we can do a merge here to merge all these things together, which gives us the grid with our frame here, which in this case is too small, right? So yeah, that's gonna be a problem here, but no problem. We can go for, before we do a poly extrude, right? We can say poly expand 2D here. Just to expand outwards, we expand the outside only. That way we're able to extend this frame out a little bit. And of course that's extending too much, so offset can be something smaller. You can hold it on middle mouse button and drag the numbers until you're happy with the result. Okay. Yeah, now we have this like a sci-fi kind of like ish grid in here. Okay, cool. Alright, so when that is done, then we can populate our plate onto our points. Yeah, so we can do a copy stamp over here from these to these. Okay, we got our stuff duplicated over there, right? Alright, so that's one thing. We can call this guy Sci-fi stair base. Okay. Oops. Yeah. And because this is like, you know, our procedural, you can get different input. If you're like thinking like maybe I want something else to be that, you can of course import something else. All the setup we have here will still be effective, so we can make the height different, can make the depth different. It should do the same thing. But there is a problem here though. You can see when I stretch it longer, this grid is not having kind of like the proper thing, right? It's kind of like getting stretched longer. So we kind of want it to be able to be more flexible when the depth is getting deeper, right? We want it to subdivide this guy more, right? So this grid subdivision here on the columns should be somehow controlled by the depths. Okay, I'm gonna copy that parameter. Okay, and let's say for every 1 unit, I want to have, yeah, the depth is now 1. Let's take a look at that. Should be 1 right away. Yeah, it's 1 unit. I want to have 1, 2, 3, 4, 5 subdivision in the middle. So that means this guy will have, let me change that to 5, and this is going to be multiplied with that, right? So 5 multiplied with the stair depth. Copy parameter, and then paste it over there, right? And then times 5. Okay. Let's see how this works then. We're going to go and drag down the depths. You can see how it's shrinking, right? Of course, it's going to be somewhere in between. It's not quite correct, but you know, this is better than nothing, right? So it's able to update it when needed. Because this is a float, well, this is going to be converted or rounded up to integer in this case. Anyway, cool. So yeah, that's going to be basically, you know, this. And then we can then think about like how does this side work, right? We have our basic structure here with the points, right? We also wanted to have a side for that, and that's going to be basically this point and the point before the last. We can have a line, right? And we can get something, we can get a middle point there maybe, or we can just model it over there actually. Yeah, let's do that. So we need to know those 2 points, the first point, right, and then the point before the last one. Okay. All right. And so we can say int last point will be equals to that, right? But that's point 19. And then what I need to do is I need to group the first point and the one before the last point. We can do it here, or maybe we can do it somewhere else. Right. So let's just do it with a new wrangle, because it should be very easy to do actually. So we don't need to do it here now. We can easily capture that. So getting into the details here, we can say int first point will be equals to 0 for sure. Int top last point, right? This one will be the number points of our geometry. Okay, right? And then we can set point group for those 2 things. 0. We can say this is going to be the side trim, right? And then we can do first point and then 1. We can do the same thing for the top last point. So now those 2 points will have the group that I want. Okay, but again, this is like coding way of doing this. I'm pretty sure there are other ways of doing this, but this is just my way of achieving stuff. Anyway, so this is going to be grouping side trim points. Okay, and then we can blast these out. Okay, and blasting the points, we can then choose the set trim. Okay, and delete non-selected. Right, got only point 1 actually, which is weird because this one, let's try that. Maybe I was choosing the wrong one. Maybe let's take a look at that. Set trim, set point attribute, top last, number points 0. How many points do we have in here? 1. That's interesting. Number points. Oh, you know what? That's wrong. That's number points minus 2. I don't know how I come up with the idea of number points. Yeah, that will be those 2, right? And we can do a add sub to add our points by group, right? To add our little line there. And this line will be the line that's kind of like if we template our shape. You can see this line is basically you know, tilted this way, right? And we can make the line extrude this way or the other way just to get the shape we want. So let's do that. Okay, First of all, attribute wrangle here, I wanted to define the normal direction. At n would be equals to the direction of the x should be just 1. So 1.0.0, right? And then we can say extrude. To extrude it out this way, I'm not seeing anything. Let's see. Extrusion is going to be polynomial. Yeah, that would. Did I do it on the polynomial? Let's take a look at that. Yeah, it's going towards that direction. So if I extrude this, it's not doing that for some reason. Normal direction is correct. Maybe I can promote it to the primitive, maybe. So we can do that on the primitive and see the normal is there. It's not quite happy on what's going on in there. Okay, well, let's see what's going on then. 0, 0, 1. Maybe we can do another transform. So we're going to transform it forward on the x this way, right? And then we can do a merge. And so we got these two, and we just 0, 1, 0, 2, 3. It's going to be our order of creating our shape, so we don't need the add sub at all. Just don't care. We do it in here. Attribute wrangle here, we can say, okay, for the details, we just say add primitive. Right, we're using the number 1, 0, 2, 3. Okay, and it's going to be of the type poly. Okay, and that way I'm adding it myself. Yeah, I'm just more familiar with coding way of doing all these, but there might be something I don't know about that extruding thing. Anyway, so yeah, we got this thing extruded out, and this is our frame, right? This is our platforms, and this is kind of like our frame. And I think we should move it actually the other direction instead. So -1. Right, that should cover it. I wanted to move it to the edge of this, right? And that edge will be determined by the width of the grid here, this one, right? So we can copy that, and then we can do another transform and transform it on the z direction, right? And that should be also dividing by 2 to get it right there. All right, and then we can do a poly expand somewhere to get it expanded like that. Okay, and we only output the outside, and we can define, of course, how much we're expanding this, right? And then we can extrude out the thickness by doing a poly extrude again, or the game thing, whatever. Right, we're going to output the back face. All right, and this is going to be kind of like the base in there. And let's see, maybe I'm extruding too much. Anyway, so now we have that. We could have it mirrored to the other side, right? So we can do like a mirror command. And we're mirroring it across the z direction, so this is going to be the z here and 0 there. All right, and then we can do our merge. Right, turn out that. Cool. Now we have our stair. Right, this is all built procedurally, so we can go back and change anything like the stair head. can see how it's updating down the way. Right, the depths of the stair and how many stairs do we want to have. It's all gonna be working, and we can also change the width of the stair. Which, by the way, the width should also be determining how many grid we have in here. Right, so we copy parameter and then paste relative reference in here, and then we can say maybe also 5 times that. Okay, so that way we're getting updated grid size here also. All right, now of course it would be stupid to not have a handrail down there too, right? They wanted to also implement that and create a handrail maybe from here to there, right? And then stuff's in there. Right, so in that case I kind of wanted to have a wider width in here, right? And handrail can come from somewhere here. That can also be coming from our points here, right? Those 2 points. Okay, and that can also be merged before we mirror over here, right? Before we even move it, actually. So that means it could be better to have the transform in here, right? That should still do the same thing. Cool. And then we can do a merge in here, and this merge will basically merge also the handrail on top. That way we can all mirror them together. Now this is always kind of like a debate on how do you want to procedurally make this, because if you pack everything together and then mirror it, you can do it with one mirror. But on the other hand, this mirror is mirroring a lot of geometry, which makes this node really slow. So just to get better feedback, sometimes people choose to either have a whole lot of like the same node duplicated, than trying to pass it through the same node and wait forever for it to update. Right? It's not like programming sometimes. Anyway, so yeah. Right, so we have our points here. I think this is going to be the one we can use. Let's take a look at the box in here, and our points are here. I think the points, this point is okay. On this point I want to go back a few. Or before we extrude, we got this one, right? Or this transform one. Yeah, that's the frontal one, right? That's going to be a better points we can use. And it's going to be having the handrail, but the handrail will be, you know, moving the 2 points closer to each other. That's going to be where we position it, right? So let's do that. I'm going to go for another attribute wrangle here. We can say, okay, we can say if at point, because we have 2 points right on this guy, if point number equals to 0, then other points, we can do this actually, int other point will be equals to at point number equals to 0, right? If it's equals to 0, then the other point is 1, otherwise the other point is 0. So that way with one line we can get the other points, right? And then we can say vector other point position will be equals to point of our first input, and then position, right? And then we ask for the other points, right? So get the other points position, and then we have our own position. We just used our own position to menace the other point position. We got the direction. Actually, we want to get a direction that's facing towards each other, basically. So we can say vector direction to the other point will be equals to the other point position, a normalized version of that. Normalized version of the other point position minus our position. Okay, right. And we can then say at position plus equals to the direction to other points times a channel called the handrail distance from edge. Right, and we can click on that, and now we can drag this over. You can see how they're shrinking the direction inwards. Right, we're going to place our handrail between those two, basically. Right. Cool. So what we want to do is we want to have a line going up and then goes in and goes down, right? And this could be the same thing we did here. So I'm going to copy that. Oh, actually, we just need to do a transform here to transform this entire thing upwards, right? And we can do like a merge back. You know what? That's kind of like wonky. We can just do it ourselves with another wrangle. This is shrink. Sorry, I'm keep coding, but this is just so convenient sometimes to me, but maybe not to normal, like average node-based artists. But you know, once you get used to it, it just feels like this is how it's supposed to be. Anyway, move up and connect. Okay, so what we want to do is we wanted to kind of like move the points up, right, and have two more points. Okay, so we can add point. Can say vector point 1 position will be equals to point. Let's take a look at that. The point 1 is there, right, and point 2 is there. So point 1 position will be point 0, and then P, and then 0, and then point 2 position will be point 1, and then P, and then oh, actually 0. 0 is the first input, so we don't change that, and that's the different number here for the last argument. We've got those 2 points, right? And then vector point 3 position will be equals to point 1 position plus a height, right? And then we can do the same thing for point 4. Will be channel point 2 position plus channel plus height, yeah. And then we can say int point 3 will be equals to add point, right? When adding a point on point 3 position, right? And we do the same thing for point 4. So point 4 position will be that, right? So we're gonna add those 2 points. Yeah, let's take a look at the result. I'll click on that to add the hat, of course. Yeah. Oh, we're adding that. That's not cool. We're gonna set a value from 0 because we're adding one attribute is gonna a float number to a vector is gonna add on all 3. And that's not cool. So we're gonna add only on the y-axis in this case. So we're gonna have to convert or construct a vector in this case that's only gonna have a value on the y. Right, that way we're adding that. And in the height, I can go to the settings and define the height value to be ranging from 0 to 5 maybe. That way we can drag further. Okay, and we can connect our handrail this way from 0 to 2 to 3. 0 to 2, 2 to 3, 3 to 1, right? So we can add add primitive. Okay, 0 polyline, and then this polyline will be 0, and then 2, and then 3, and then 1, right? I'm adding that polyline here. Building that like this. Okay. All right, and then for those 2 new points, I'm gonna give them a group and a set point group. Maybe I was using add point group earlier, that's why I'm having trouble with that. Anyway, it's behind us already. So 0, and then top corner, right? That's going to be the attribute for that. And then for P3, 1, right? And then same for P4. Those 2 points, right? They're having a group called top corner. Okay. The reason I'm doing that is kind of like I wanted to give this some roundness in there. Right? We can do like a bevel, hopefully. Right? We can go to the bevel here and the bevel the group points. Right? Do we have the group? Top corner, we have 2. Yeah, we have that group. It's not showing me that. I guess you can just bevel it because there are just just those 2 anyways. Yeah, because I'm overthinking it. Okay, so we got this bevel here, and this is going to be kind of like the handrail basic structure, and we can do poly where, right, and apply that. Right, this is our handrail, right? And there's something really weird in here. I'm not sure what's going on there though. Okay, I think we just need to do the normal thing so that they're having correct normals for the points. No, it's not really doing that. This one is tilted for some reason. It's not really giving me the normal direction. Okay, what do we do? Well, we can do one thing, which is sort. To sort this thing based on the vertex order, that we have this like 0, 1, 2, 3, 4, right? And yeah, that polywire then works because I guess it's based on the order, right? And then we can change the divisions, right, to have it like more like a rounded cylinder, a cylindrical shape, right? Cool. So now we have this handrail. Cool. And then we can, yeah, that's the merge I want to go for in there. And that should populate everything, right? And this looks way more cooler than before because we have the handrails added into this. And basically, I think the position is kind of like a little bit too, you know, I kind of wanted to put it in the middle there. So we need to move the points away. So another transform is needed to move the points away. But the points should be somewhere in the middle, right? The middle of this, so the distance will be the distance halfway through the extrude in here. So we copy that parameter here. And then we go to this transform on the z-axis and paste relative reference. But divided by 2. Right, that should put our points right here in the middle. And we got, you know, this right in the middle. Cool. All right. All right. We also even just add a few more, like, you know, vertical columns here in the middle for the handrail, just to have some fun with that, right? So to be able to do that, what we can do is we can find the points again, right? Right. This is our point. Not sure what that is. Could be fun. Yeah, I should have only 2 points. Yeah, that's good. And then I can do a add here to have a line. Okay, and then we can do a resample to resample this line to, you know, a bunch of smaller lines. And of course, we can change the length to determine how many we want. And we just need to populate a few cylindrical shapes down there, right? We can do one more attribute wrangle here and say its normal for every point will be equals to a value of 0 to 1 to 0, right? So that way they're facing up, right? And we can create a cylindrical shape going up there. Yeah, this is the height we want to go for, so I'm going to copy that parameter. And then that's going to be the length of our new cylindrical shape. So we can do like a tube to do that. Right, and we can go to the height and paste the relative reference. Okay, so the tube is also that height is going to be polygon. And we can lower down the radius. The radius will be again based on the same as our polyware, but maybe slightly smaller than that. So we can go here and say this, but then we in minus 0.01 to make it thinner, right? And that will be copy stamped. Okay, and you can see they're doing, you know what, we can do this actually. Transform using template point attribute should be turned off. Yeah, that will be the way we need to do to get it work. And yeah, we just also have to bring them up, and that should be very easy. We just copy the height here, and for the center we just then paste it and then divide it by 2 to have them positioned right there. Right, that's going to be our little columns. Right, that can be also merged together with it. And that's going to be positioned in there. So now we got this really cool structure, except those two. Sorry, excuse me. So yeah, should do that on the shrink. Yeah, let's do that. Yeah, and even that, I think we are having the problem because you don't want those 2 points on the very edge, right? We could probably blast out those 2 before we do the attribute wrangle here. We don't need that attribute wrangle. So yeah, we can just make this the one that delete the last delete 2 ends, right? We don't want the 2 ends in there. So instead of doing normal, we can say if at point number will be equals to 0, right? Or at point number equals to number of points minus 1, right? If it's the first or the last point, basically, and we remove points. Zero and then add point number, right? Double equal here. Okay, that should bring those 2 points away, and then we can then copy, and that would work better, right? Cool. So now we have the merge in there. Now we have this even cooler structure, right? They're all procedural again. So what you can do is you can still go back here to the very first setup. We have the settings for these guys, right? You can tweak those things, right? And it's going to update down the way. Pretty cool, right? This is all done procedurally. All right, and this is almost like 40 minutes. I think that's about the time I have to do this. And I think I was talking about like doing like a full bridge with maybe something probably in the middle, but you know, we can do that real quick actually. Maybe it's not gonna be super hard because all we have to do is basically have another structure over here, right? Maybe it's gonna be another grid with the size we defined and with the settings for like the grid here in the middle. So we have a bigger piece in the middle, and we add, you know, some extension here for the frame, and we add handrail basically in the middle. So Shouldn't be difficult to do. Yeah. So we have this grading here, and maybe, yeah, we have this merge, right? And let's try to mirror it to the other side and go for like a transform here and drag it away on the x-axis. Okay, and then we have a mirror to the other side by doing a mirror. Right, and then between those two, we wanted to have like a connection, right? And the connection can be just a big grid or a bunch of those grids populated. I'm not sure. I'm not sure how do we do this. Now let's just have some fun with a whole lot of grid like this in the middle, right? So this is that, and then we can do is we can get our points in the middle. That's our find anything here. That's the highest point in there, right? And then we can have a reference of that. Okay, so got this point, right? And then we transform it. Let's see, this is in there. We can create a null node in here actually. I wanted to transfer it also over there and have a duplication. So we can right click, there is a action, we can create a reference copy, and that goes in there. So we're moving that point also to there, so that we have this point position in there. Right, we can then also mirror it. The mirror should be the same, but we can also do a reference copy there. So we mirror the points to the other side. Okay, we'll do another attribute run go and say if at position dot y is smaller than 0.1, then we remove the points. So that way we're removing the bottom points basically. Right, to leave as just the top points. Okay, so we have those 2 points here. We can then do an add, right? And for the add, we're just going to say backgroup. That's just going to add a line here, and we just resample it. The resample, however, will be kind of like based on the size of our little grade here, right? So we can get our grade, okay, and then and put it in here, right? And we can do another attribute run go here. I'm doing too much run go. Get size, and that can go to the second input. Okay, I need to know the size, the width of the x-axis. It should be very easy to get. In the details panel, we can say vector grid size will be equals to get bbox size of our grade 0, and then actually 1 this time, right? And then we can say f, or yeah, just at width, not width actually, this is going to be the depth. Grid depth will be equals to the grid size dot x, right? So that way, if you go to the geometry spreadsheet, you're able to see in the details panel we have this grid depth here, right? This is how deep this is, right? For every grid, and based on that, we can divide this line to also that much, right? So for this for the resample, we're going to do after the add. Now the resample, we can then do resample by polygon edge. And for the length, this length is going to be the length in here, right? When this length has to be the width of this guy. Okay. So we can say, okay, this guy will be the detail attribute of our current operator input pass of this object, and then first input attribute is called grid depth. Okay, and then 0 for the first index. Okay, that way this width is exactly going to be the width of this, right? Which is cool. And then we can basically populate it this way. Okay, but you can see there's some slight problem here though. This point has to be over here when we're doing that. So I guess we just move it halfway there before we do this. So in the transform, we have it in here, right? And then we do another transform. Okay, we're gonna move it on the X direction that much also for the width. So that means that it could be easier to actually do that all the way in here instead. Okay, so that way we can go back here to the resample, copy that, and go to the transform here. We can transform it on the X direction this much, and then divide it by 2. So that way when we're placing the first grid, it's going to be in the right place already, right? And maybe a little bit over that, plus just a little bit, right? Cool. Now these points now are going to be where we populate our grid again. So we don't know the attribute run. Sorry, not attribute rango anymore. Copy step. I'm going to copy our grid over to this guy, right? So that way they're going to be placed exactly, no problem touching each other exactly there, right? So we can get it work like that, and then we can basically now do our merging in here, right? And we got the platform populated down there too. Actually, not down there, on there too, right? Right, and then we can change how long this is by going to the transform and change it so it's wider or shorter. Right, it's gonna populate accordingly. You can even go negative direction to have some fun with it. Right. Now this could have some imperfections here and there because when we're dividing it here, it's not guaranteed to be evenly spaced, to have the certain amount of this length. So that would be some limitation. We could force it to be like that, because the translate here, right? It's an arbitrary number, but we can change it to a certain number that has to be like multiplied by the width of this. But just for the simplicity, I think this is working in most of the cases anyways. So yeah, it's fine. And then you can use the same method to do the handrail already, right? So in that case, we got our 2 points after the mirroring, right? Let's take a look at that. Actually add this here. And I guess we can populate handrail based on what's going on in here already. Let me grab all these guys together. Because these are going to be the thing that makes the handrail. We can make a subnet out of it. Oh, forget to have that selected. Yeah, right, this entire piece. We can make a subnet here. We can say make handrail. Right, and this one does that for us. We can basically copy that and go here to our mirrored points, this one. Right, we can use that to also make handrail. right, to make our handrail there. And this one will be also merged. Oh, you know what? We cannot do that yet, but yeah, we have this one. We just need to kind of like move it to the side. Again, that's going to be the same transform here and the same mirror here. Right, we can go create a reference copy of these two and then drag them over here. Right, and that goes to the merge. Right, cool. So we have those set it up properly also, and then that merge eventually goes to the last merge. Right, I'll have all these things built up. Right, this platform is gonna be, all good. All right, so yeah, that's gonna be some like extensive, not very extensive, but kind of like a little bit more advanced ways of like building stuff with Houdini. I think we're maybe only missing some supporting, but that should be very easy to do because we have done the tilted one already. Yeah, I'm not gonna show you that part because the video is getting 1 hour already. But building something like this in 1 hour with Houdini Procedural and being able to make changes is not a huge waste of time, right? Doing that from scratch maybe will take quite a few minutes, 20 minutes, I guess, or so. And again, this really perfect alignment will be even more difficult, right? And this is all done procedurally, and you can make changes to almost a lot of aspect here, like the length or whatever, right, of this. And you can control the stair, right, stair height to have more or less stair in the depths of the stair, right, and then the stair count to have more or less stair. It's all gonna be procedurally able to build it without breaking, right? So again, that's the power of procedural modeling. Okay, cool. Yeah, that's it for this video. Thanks for watching. See you next time.